Chapter 3, Exploring Linux File Systems. In this lecture, we're going to introduce the Linux directory structure. Most of us come from a Windows background, and under Windows, the directory structure is broken out by hard disk. For example, right here, the C drive, and then underneath the C drive, we have the Windows folders, and then under the Windows folders, other folders. And it's kind of a hierarchical standard where everything comes together at the drive level. But what about when we have multiple drives? And many Windows systems do, especially in enterprise. Well, you have to go to a completely different drive. So here's a D drive with its own hierarchical folder structure. We can see it right here on a Windows command prompt. Here I am sitting in my home directory, more on that to come later, under the C drive in a folder called Users. If I go just to the root of the C folder, here's all the directories that are directly underneath C. Program files, x86, all that kind of stuff. Unreal Tournament 2004. Yes, this is my gaming machine. Linux, however, does it completely differently. Linux uses a hierarchical structure that is not based on hard disk or any other storage media. It's all based on this. At the very top of the Linux directory structure, we have slash. And that's not the guitarist from Guns N' Roses. That's slash meaning root. This is called the root of the file system. And this is not to be confused with the user root, the super user root, the administrative user root on Linux. Totally different subject. This is the root of the file system. And underneath the root of the file system, we have our folders. In Linux, known as folders, directories, whatever. And within those folders and directories, other folders and directories, and so on and so on. These can get very, very deep, going down many, many layers. Now, if we take a look on a Linux system, here's our Linux terminal window. Notice, as logged in as a user Bob, I'm also sitting in my home directory. Remember that little tilde right there, that little worm? That's shorthand for our home directory. And this is where some of those commands that we introduced last week come into play. If I run a pwd, present working directory, it shows me that I'm under home Bob, so Bob's home folder. This is the Linux equivalent to that Windows home directory I was setting in just a minute ago. If I use another one of my commands from last week, cd, change directory, I can go directly from my home directory to the root of the file system. Notice right here it shows my current directory having changed. Now if I do a directory listing, here are the top-level folders of a Linux system. Now these are standard. These aren't going to change much between system to system, although different distros do have slightly different ones. Many are consistent. For example, the folder home, right there, is where the user home folders live. And inside of that folder, and again, remember, these are folders. We can tell that because in this bash terminal, they're blue. Inside a home, I can have many, many different users. I can have hundreds of users, all of them existing within the home directory. There's others, though, and there's other system folders that we're going to become very familiar with over the next weeks of the semester. A big one is this one right here called Etsy. We took a look at that one last week also. And if I cd into Etsy and do a listing, we can see what's inside of here. Mostly plain text configuration files. Plain text, meaning it's just text, just plain ASCII text. No special formatting, no meta characters, nothing like that. And these are configuration files, so things like nsswitch.conf, nfmount.conf, configuration files. These files all control how the operating system functions. And as admins, we actually spend a lot of time in here manipulating these, getting the system to do different things. Let's go back up to root again. Another one? How about this bin folder? Bin, that stands for binary. So what's inside of the bin folder? Executable files. These are binary files. These are programs. Really, components of the Linux operating system. Now, one thing you will notice, I've got a bin, and then right here I've got another folder called sbin. What's the difference? Programs in the bin folder, any user can run. They're unprivileged programs. Programs in the sbin folder, actually that stands for super user binary programs, are administrative programs. In order to run these, you have to have root privileges. That's the administrative user root, not the file system root privileges. Regular users can run the programs within bin. Root can run the programs within sbin. What's this root folder right here? Well, that's actually the user root's home directory. The user root doesn't have his home directory in the home folder. It actually sits directly underneath the root of the file system. Other ones. We have a folder here called dev. These stand for devices. Now here's a key point. In Linux, everything is a file, including the hardware. Or at least the hardware is represented by the file. And under dev is where they exist. Remember last week we talked about what a terminal window actually is? We said it's a TTY, a teletype, really? Well, here they are. They're represented in the system as files. Other devices, FD0, that stands for floppy disk. Now this system doesn't have a floppy, but if it did, that's the file that would represent that piece of hardware. SDA, SCSI disk A, SCSI disk B, C, and D. Because our system actually has 4 physical hard drives in it, well, 4 virtual physical hard drives. Disk A, B, C, and D, and here they are represented by their files right here. So when we do things to act on those hard disks, we're going to be acting on these files. That's how that works. Another important folder we want to see, var. Now var stands for variable, meaning variable size. And really, the stuff that's in var are things that change a lot. Primarily, things like system logs. So all the system logs that are maintained by the Linux system by default, although applications will keep their own in different places, by default, they're stored under var log. And if I descend down into the log folder, here are a bunch of different system logs. So we have the dmessage log, we have the mail log, we have messages, which by the way is the primary Linux system log, the yum log, and all that. We explore these later on. Another folder we should be aware of, USR. Now that looks like it says user. It doesn't stand for user. It actually stands for Unix System Resources. And really, this is where programs can be installed to. This is where a lot of the libraries live. Now, libraries, what are libraries? They're code that backs up other code. And if you were to install games in the system, for example, there's a games folder here for it to go. And see this bin and Etsy folder? These are not the same bin and Etsy folders as we saw under root. Remember, I'm under /user. So if I change directory now to this Etsy folder, notice where I am, /user/Etsy. Now in this case, there's nothing in that folder. We haven't installed any programs on here yet that make use of it. But it's important to keep in mind where you are in the file system. Right here, I'm under /user/Etsy. I just CD'd to the /Etsy folder. See the difference? Directly under the root file system. That first leading slash in a file path, that represents root at the top of the hierarchy tree. And there's all our plain text configuration files that control the system. Probably helps if I spelled that right. There we go. Go ahead and look around and explore. As a regular user, unprivileged user like Bob, there's not really any damage you can do. If you're doing it as root, we could really tear things up. But as Bob, go ahead, take a look. The key takeaway here is that each of these high-level system folders are there for a specific purpose, and they do various things. Again, the commands that we were using, pwd, works really well for figuring out where you are. This is useful because this directory structure can get very, very deep. You can be many, many layers of folders down and get yourself turned around. pwd will tell you where you are. cd obviously changes the directory you want to go to. And we already discussed some of these different file types. Text files, plain text files. Just nothing else in there, just ASCII text. The second part of this lecture goes into more detail on text files and how to view them and how to edit them. We also have binary data files, right? These are the compiled programs, generally executables. An executable program file is something that I can run. Directory files. Those directory folders are actually a type of file. Under Linux, everything is a file, including directories. But really, they're just files that point or contain other files. We saw what a lot of these file names look like. Every file has to have a name of some type. Well, under Linux, they can be up to 255 characters long. That's a long file name. And they can use all the special characters, well, some of them anyway. They can use things like letters, numbers, underscores, dashes, periods. They can't contain things like question marks and asterisks and things like that. Those characters have special purposes. Now, many files will use something called a file extension. And we see this under Windows all the time. This is the way it's been since the old DOS days. Like, for example, right here, we can see this file, this vcredist.bmt. This first part right here was the file name. Then you have a dot, and then you have the file extension. The purpose of a file extension is to tell the operating system what kind of program to use to work with this file. So in this Windows example right here, this .bmp, that's a bitmap image. So Windows by default would open that with like Paint or whatever other graphics program you have for opening up images. Look at this guy up here, log.txt. TXT stands for text file. So Windows would use Notepad by default to open this file up. Under Windows, file extensions are pretty much required. They're strictly not, but the operating system gets really confused if you don't have one on there. Under Linux, we're allowed to have file extensions, and you can certainly use them, but they're not quite as required as they are under Windows systems. In fact, we saw under Etsy, a lot of those plain text configuration files had no extensions whatsoever. In Linux, the file extensions do have specific meanings, just like they do under DOS Windows. So, for example, .txt is a text file, .conf, .cfg, those are configuration files, .tars are compressed archives, .gzs are just compressed files, .shells are shell scripts, and so forth. There's many more than this. Linux will use the file extensions if you make use of them, if you put them into the file name. If you don't have a file extension on there, then you're the one that has to know what kind of program needs to open up that file and to call it manually. We looked at the ls command, right? That's the command that displays the contents of our directory listing. Now, remember last week we talked about help pages, things like the man pages and the info pages. As we start going through these commands, make use of those help screens. A lot of the things we need to do from this point forward will be to invoke the help functions. So what are they? What are the switches we can use? What are the arguments? Your help functions will tell you that. This concludes our intro to the Linux directory structure. In our next lecture, we're going to go more in depth into plain text files and how to edit them.